Hi math students, it's Mrs. Marcellus in Einswine. Just as he promised, he's here to help us with our unit on multiplying and dividing fractions. Besides every fraction being a division problem, Einswine says that every fraction is also a fun-filled adventure. Isn't that right, Einswine? So we figured, what better way to have a fun-filled adventure than a trip to the amusement park? So math students, please remain seated in an upright position and keep your arms and legs inside the desk at all times. Here we go! Today's learning objective: students will find the product of a fraction and a whole number by using area models and applying standard algorithms. If you remember from a previous unit, a standard algorithm is simply a standard process. To multiply fractions and whole numbers, we will write the whole number as a fraction, and to do that, we'll put the whole number over 1. Then we'll multiply the numerator straight across, multiply the denominator straight across, and simplify. Another important word is commutative. The commutative property states that the order can be switched and you will still get the same result. All multiplication is commutative. For example, 3 times 5 equals 15, and 5 times 3 equals 15. This applies to both fractions and whole numbers. So what do you say, Einswine? Are you ready to begin? Okay, then let's go to our first example. In our first problem, we'll find the product of 2 and 2/5. One way to figure this out is to draw a model. As you can see in the drawing, there are 2 whole units. Each of those units is divided into fifths, and 2 of the fifths in each of the 2 units is shaded in. If you put all of those pieces together, you would end up with a total of 4/5. So 2 times 2/5 equals 4/5. The multiplication by itself looks like this. We will put 2 over 1 and then multiply it by 2/5. To multiply, we multiply straight across. The numerator times the numerator would be 2 times 2. 2 times 2 equals 4. Then we multiply the denominator straight across. 1 times 5 equals 5. So our answer is 4/5. You can see that our answer matches the model. In this problem, we have 3/4 times 5. If we drew a model, we would have 5 whole units, and each of those units would be broken into fourths. Then we would shade in 3 of the fourths in each of the 5 units. If we counted up all the shaded pieces, we would have a total of 15 shaded parts. So 15 fourths are shaded and 5 fourths are not shaded. The multiplication looks like this. First we write 5 over 1, then we multiply straight across. The numerator times the numerator is 3 times 5, or 15. The denominator times the denominator is 4 times 1, or 4. So we get an answer of 15 over 4. However, that's an improper fraction, and we want to write that as a mixed number to get our answer in final form. In order to do that, we have to figure out how many groups of 4/4 we have, and then how many fourths will be left over. Often you can simply do this mentally, but if you aren't certain, you can always write out the division problem, because as we've learned, every fraction is a division problem. We would take the numerator of 15 divided by the denominator of 4. 3 times 4 is 12. Then we subtract, and we have 3 pieces left over. That means we have 3 whole units of 4/4, and we have 3/4 left over. So 15/4, written as a mixed number, is 3 and 3/4. We probably won't want to draw a model every time, so now we can just go ahead and do the multiplication. First we'll write the whole number over 1, and then we can multiply. We'll multiply straight across, numerator times numerator, so that gives us 7. And then the denominator times the denominator is 2. However, we don't want to leave this improper, so we ask ourselves, how many times will 2 go into 7? And you can always go off to the side and do the division problem if you choose. And 3 times 2 will give us 6. And we subtract, and we have 1 piece left over. 7 halves equals 3½ At Stan's Sweet Shop, each serving of cotton candy is made from 7/8 cup of sugar. What is the total amount of sugar in 4 servings of cotton candy? In order to solve this problem, we'll need to multiply. We'll multiply 7/8 cup times the 4 servings. 7 times 4 is 28, and 8 times 1 is 8. However, we don't want to leave this as an improper fraction, so we can figure out how many times will 8 go into 28. 8 goes into 28 3 times. 3 times 8 is 24, and that leaves us a remainder of 4. Therefore, we'll write 28/8 as 3 whole cups and 4/8. We always want to write our answer in simplest form, so we're not quite there yet. We can simplify 4/8 by dividing both the numerator and the denominator by 4. And when we do that, we end up with our final answer of 3 and 1/2 cups of sugar. There are 28 bumper cars available at Crasham City. If the ride is 6/7 full, how many cars have people in them? We'll solve this using multiplication. 6/7 of the 28 cars have people in them. We'll write our multiplication problem. 6/7 times 28 over 1. 6 times 28 equals 168, and 7 times 1 equals 7. Next, we have to figure out how many groups of 7 are there in 168, and we do this by dividing. And this gives me an answer of 24. That means that 24 of the 28 cars at Crasham City have people in them. Phew, I don't know about you, Einswine, but right about now I sure am wishing that we had done the bumper cars before we ate all that cotton candy. You know, maybe it'd be a good idea to go check out the high dive show before we go on another ride. So, bye for now, math students.